question 44 on page 150. And what we've got is we've got a formula here. And this is the height of a projectile when it's launched up in the air. So here's our formula, and we're only going to do 44. So a projectile is launched from ground level with an initial velocity of v0 feet per second. Neglecting air resistance, its height in feet t seconds after the launch is given by this formula. Now, what we want to do is we want to find the height that is the time that's going to take to reach a height of 80 feet, and then also return to the ground with the v0 of 128. So let me draw a diagram to kind of show you what's happening here. And there's three different scenarios. What we can have is we can have a rocket, and it's here. And this rocket's going to go up in the air, and it's going to come back down. And this is going to represent our height here. Now, let's say our height was 100. So if I have a height of 100, what happens? It crosses this curve twice, right? It crosses once on the way up, and then it goes up and hits a maximum, and then it comes back down. So if the picture looked like this would have two solutions. It's going to have two solutions because you're going to hit the 100 feet when you go up, and you're going to hit it again when you come back down. So you can have two solutions. You can also just have one solution, because if I draw it, let me try to draw this better here. If I draw this picture here of, again, the rocket ship going up and coming back down, and I put the height up here at, let's say, 150, see, it would touch this at one spot. So it could touch the maximum, and that would only have one solution. Right? Because there's going to be only one point at which that height would touch that graph. And the last one that could happen is you could have no solution. Well, how could you have no solution? You can have a rocket, again, going up in the air. But you can ask yourself, well, how long would it take for this rocket to, let's say, reach 300 feet? Well, 300 feet is above, right? And it never reaches 300 feet. It's always below that, so this one has no solution, because it never can reach that 300. So those are the three scenarios that you can have. One solution hits that maximum. Two solutions going up and back down. And no solution because it never reaches it. Now, if it never reaches it, that means you're going to get non-real complex answers. So if you get non-real complex answers, that means you're asking it to do something that can't be done. You're asking this rocket to go up 300 feet, but it can't do it. So it never returns a real solution. What you would get out is non-real complex solutions, so that means there's really no solution. So now let's go back to our formula, And we're going to talk about all the pieces and what they mean. Okay, now, S represents the height. So that's the height that you want to go. T represents the time. V naught, that represents the starting speed or starting velocity. Now let's think about if I throw something up in the air. If I throw a ball up in the air, what happens? That ball goes up and it comes back down, right? Now, the harder I throw the ball, the higher it's going to go. But it's eventually going to come back down. Now, what's going to force it to come back down? Gravity. So this minus 16 here, that's your effects of gravity, simplified a bit. And then this V naught, that represents how hard you throw it. The harder you throw it, the higher it's going to go. And time represents how long it takes for it to get up to that height and come back down. So we're looking at question 44, and they give you a V naught initial velocity of 128. And for part A, we want a height of 80 feet. So that means then that S is going to be 80. So we're going to plug in our values. We're going to plug in our initial velocity of 128. We're going to plug in an 80 because that represents the height that we're trying to attain. So 80 is then going to equal a minus 16t squared plus 128t. And now we know what to do. Now we set it to 0, and we work with it from here. And it also says round to the nearest hundredth, so we may have to use the quadratic formula. But let's go ahead and move that over. And let's see what we've got here. We've got all even numbers, so there's at least a 2 in there. Can a 4 go into all those? I think a 4 can, can't it? Yep, 4 goes into 80. 4 goes into that 120, and 4 goes into that 16. Does 16 go into them all? Let's see. 128 divided by 16. I think that'll work. Yep, that's 8. 80 divided by that 16, that's 5. So it looks like we can divide everything by a 16. Now, when we work these out, we never want to have a negative x squared or a t squared. So to avoid that, we're going to go ahead and divide everything by a minus 16. That's going to take care of the sign, and that's going to take care of our numbers as well. So it's going to make it a little bit easier to work with. And now we've got t squared and 128 divided by that 16. Switch your signs. It's going to be a negative 8t. Negative and negative makes it a positive 5. So is everyone okay with that so far? Now this is an example of a question where we cannot use zero factor. And why can we not use zero factor? Well, first off, we need to find two numbers, multiply together to give you 5, add together to give you 8. There's no two numbers that'll work because 5 only has 5 and 1. And 5 and 1 is 6, but we need what? We need 8. So that's not going to work for us. So what we're going to have to now do is we're going to have to try and apply the quadratic formula. And it says round the answers to the nearest hundredth. So at the end, we're going to round it to, remember, what do we know about places? Tenths is 1, hundredths is 2, thousandths is 3. So we're going to get this to 2 places at the very end. We'll keep it to 3 as we move along. We want it to eventually end up with 2. So if we want to use our quadratic formula, Our A is 1, our B is a negative 8, and our C is going to be 5. Let's write up our quadratic formula. And our quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. We're going to plug our pieces in. So that's a negative of a negative 8 plus or minus square root then of negative 8 squared minus 4 times 1 times 5 all over 2 times 1. And this is a good review of the quadratic formula. Now, once we're finished with this one, then I think we're going to go through the homework, and we're going to talk about some of these, and I'm going to help you set some of them up. Not all of them, but I'll help you set up some of them from your homework. So let's go ahead and break this down a bit. Well, what do we know? We know the double negative here makes this positive. So now let's see what we've got. We now got 2 plus or minus, and, or sorry, 8 plus or minus, not 2. I don't know why I wrote that down wrong. The 8's on the top, so it should be 8 plus or minus. And then 2 times 1 is 2. We've got our square root, and we do that over here because that is our discriminant. And that's a negative 8 squared minus 4 times 1 times 5. And 8 squared is 64. And then we've got a minus 20. And 64 minus 20, that comes out to be a 44. Now, when we worked on these questions back in 1-4, we always had to break up the roots. But in applications, it says we can use decimals. So we're going to make our life easier. And instead of breaking up that 144, it says use decimals. And we always want one more decimal than we actually need. So we want to end up with hundredths. So tenths is 1, hundredths is 2. We're going to take it out to thousands, which is 3, round it to at the end. So let's take our calculator, and let's take the square root of that, 44. And we're going to round that now to 3 places. So that looks like 8 plus or minus 6.63 if we round 3 over 2. Is everyone okay with that? So we just used our calculator. It says round. Whenever it says round, you don't have to break up the roots. Just use your calculator. Let's get our 2 possible solutions. And they're both going to work, right? Both going to be positive numbers. Let's check and see what they would be. So on the first one, we've got 8 plus 6.633, and we'll divide that by 2. And so that gives us then, now rounding to 2 places, that gives us 7.32. That's one solution. And what's our other one going to be? Let me move it over here so you can still see. The other one, it's going to be 8 minus 6.633, and then divide that by 2. And if we round, it looks like we get a 0.68. So these are our answers, and these are going to be in terms of seconds. Now, why do we have 2 solutions? Well, we have two solutions because what's happening is this rocket is going up. It's hitting 80 feet. It's going past the 80 feet and eventually it's coming back down. So it takes less than a second to get up to 80 feet. It continues on and it takes almost 8 seconds, well 7.5 seconds basically, to come back down. So that's why you get two solutions, right? One is right there real quick because it might go up to 1,000 feet. I don't know. But it's going way past 80. And eventually it's going to have to come back down. That's why you get the two. Now what about part B? Okay, part B is the easier part. And part B says return to the ground. Well, if I wanted to return to the ground, what does that mean? If I wanted to return to the ground, well, that means my ending height, my S, needs to be 0 because that's the height of ground, 0. So we're going to get this where we have an S of 0. So let's write up our formula. S equals now minus 16t squared. We'll go ahead and plug in our 28t because that's our velocity. And we know we want this S to be 0. And now we can solve this. This is going to be a classic example of zero factor. It is set to 0. And I can factor something out. Let's first see if I can divide. Can I divide everything by something? Yeah, because 128 and 16 are both divisible by 16. It's negative, and I don't want negatives at the very beginning, so let's divide by that negative 16. Get rid of that. And I'm going to rewrite it so it's in the correct order with my variables on the left. So that's going to give me a t squared. 128 divided by a negative 16. That should be a negative 8t. And then 0 divided by any number is 0. And now we can solve it. Factor your t out. So that leaves you with a t minus 8. One solution is t equals 0. The other solution is going to be t equals 8. Now the 0 is not a solution. Why do we have the 0 in the first place? Well, when we look at this problem originally, what's the height of the rocket when I go light the fuse? When I go light the fuse, it's on the ground level, right? So it's at 0. So it starts at 0. That's why one of our solutions is at 0, because at time 0, it's sitting on the ground. And then once the fuse is lit, it goes up in the air, and eventually 8 seconds later, it comes back down. So we don't need to include the t equals 0 because we know that the rocket starts on the ground. And so that's where that t equals 0 came from. Now we do have some time left, so let's go through some of these questions from our homework. Some of these I'm going to try to set up for you. I'm going to leave the equations for you to solve, but some of them I'm going to set up. About half of these I'll try to get through and set them up. I'm not going to solve them completely, but we'll make sure we know how to set them up. So let's start with the first one. A ball is dropped from a cliff that is 320 feet high. The distance that it falls in t seconds is given by this formula. How many seconds will it take for the ball to hit the ground level? Hit the ground. Now, S represents how far it falls. So S equals the distance to the ground. Distance it falls. And so our formula is S equals 16 t squared. It's kind of like the other one. They just rewrote it so that 16 was positive because you're starting up instead of on the ground. So this one, you got a ball up top here and you're just going to drop it. And gravity's going to make it go faster down. So that's why it's the opposite way. Now, if I want this to fall down and reach the ground, how many feet is it going to have to fall? Well, it says that cliff is 320 feet tall. So that means then my S is going to be 320. Because that is 320 feet to the ground. That 320, that represents the feet to the ground. So now you've got this equation and you can solve it. All you had to do on that one was just plug that 320 in for S, and you can use the square root property. Question 2, I'm not going to work on this one because we've already done one almost exactly like it. And this is going to be set up like question 37. On page 150. We did that one earlier today. It's the sprinkler problem. Question 3 is a more difficult one. So question 3 is going to require us to draw a diagram. A boat is 92 feet from the base of the cliff. If the distance from the top of the cliff to the boat is 23, less than twice the height of the cliff to the water, find the height of the cliff. And we want to round this to the nearest tenth of a foot. So the boat is 92 feet from the base of the cliff. So what we've got is we need to come up with a triangle. And how are we going to come up with that? Well, what we've got is we got this. We've got a boat in the water. And we've got a cliff over here. And what we're going to be doing is we're going to be tossing a rope down to the boat. So the boat is 92 feet from the base of the cliff. If the distance from the top of the cliff to the boat is 23 less than twice the height. So that's going to be 23 less than twice the height, so that's going to be 2x minus 23. So that's this piece right here, because that's how far it is. Let me move it up here. That's how far it is from the cliff to the boat. If I put a rope out to the boat, this is what it would be. 2 times the height minus 23. Now, we don't know the height of the cliff. That's the unknown part, so that's going to be x. And then we do know that this boat is currently out 92 feet from the cliff. So our triangle then will look like this. Our triangle is here. And this is your C, this is your A, and this is your B. And I think you can finish it from here. Because how would you finish it? You would apply your Pythagorean theorem. This one's going to take a bit to go through, but apply your Pythagorean theorem. Now, if you get 2 solutions, you've got to make sure that neither one of them are negative. So they both have to be positive solutions, because this is a height. Question 4. A building needs a ramp to make it handicap accessible. By law, the ramp must run 10 inches horizontally for every 1 inch of rise, because it can't go up too fast, because then the wheelchairs and things couldn't go up it. So you got to make sure it's a 10-to-1 ratio. The surface of the ramp is 57 inches. How far above the ground is the inclined end of the ramp? So we know this ramp is 57. So that's what we got so far. So it tells us right there, it says this ramp is 57 inches long. Now we know it's a 10-to-1. ratio. What we don't know is we do not know the height of this ramp. So this height is going to be x. No, we don't know. But what we do know is for every inch that we go up, we have to go over 10 units. So if this is x, then this one has to be 10x, right? Because it's a 10-to-1 ratio. And then you can finish it from here. Because you'll just simply apply Pythagorean's theorem. Right? It's 10-to-1 ratio. The 57, that represents this length here. I'm going to leave question 5 for you to work on your own. Now, one thing I will make sure you know on question 5, when you go to set it up, the hypotenuse is going to be the diagonal. So that's going to be your C. So when we work this out, that hypotenuse, that's going to be the diagonal, and that's going to be your C. Now you're going to make a triangle, and you're going to solve that triangle the same as we did the others. So when you see the hypotenuse, that just means that's diagonal, and that's going to represent your C. Question 6. Height of a box is 6 inches. Its length is 1 inch more than its width. Find the length if that volume is 126. So we've got a box. So it's a rectangular solid. So it's going to look like this. We know that this box is 6 inches high. So that's your height. We know that it is 4 inches longer than it is wide. So the width is going to be x. The length is x plus 6. We also know that the volume is 126. And that volume is the length times the width times the height. I think you should be able to at least try to get your equation from here. So all you've got to do now is plug in the 6, the x, and the x plus 6. Multiply them all together, and then factor it from there. Okay, I think you could finish it from there. That should get you a good start on question 6. Question 7, we can talk about it pretty quickly here. Question 7 talks about a square. Now, what do we know about a square? Square, all the sides are the what? The same, right? So that's important. So if I give you a square, you know then that all the sides are the same. And the area of a square is x squared. And the perimeter of a square is 4x, right? Because you add up all the sides. Now, what are we looking for here? Well, it says if we read it on question 7, it says, find the length of the side if the side is greater than 1, so we've got to have greater than 1 answer. And it says the area of a square is numerically 4 less than the perimeter. So that means the area is going to equal the perimeter minus 4. And you can finish it from here because you're just going to simply plug these in. That gets you a good start. Okay, so you're going to try to finish that one from there. Now, what about 8? 8 is very simple, too. Two consecutive integers. Does it say anything about even or odd? Nope. So what's the gap going to be? Is it 2 or a gap of 1? It does not say even or odd, so that means we've got a gap of what? Gap of 1, right? How many integers do we need? 2. So the first number is x. Second number is x plus 1. And what do we want? We want the product to be 90. So that means the first number times the second number has to give you 90. And I think you can finish it from here. Right, there's nothing much left of that one. That one's really easy. Just plug the values in, set it to 0, and factor. Question 9. We did a question similar to this in 1-2. And so what we've got is we've got a quadratic model. And y is going to represent the unit sold, and x represents the weeks after the release. So y is units sold. X represents the weeks. Now, what we need to figure out is we need to see how many we sell in week 13. So what does that 13 represent? Do you think that 13 is going to be the x or the y? It says we're going to sell this in 13 what? Weeks, right? So it's the x. So that means that x is going to be 13, and all you then have to do is plug in your x. Right? If it was how many weeks it took to sell 13 units, that would be a completely different question and quite a bit more difficult. This one, though, is just saying, here's my model. How many am I going to sell in my 13th week? Plug it in, and that's it. I'm going to leave 10 for you to do, because we did one very similar to question 10 in your homework. Or not in your homework, in your review. because the question that we did that was like that one was way back at the very beginning here. But we did one just like it, and it would have been question 18. So that's going to be very, very similar to question 18, the one that we did on page 147. Okay, so page 18, page 147, question 18. That's going to be very, very similar to question 10. Different numbers is all it is. Question 11. Question 11 is the compound interest formula. And so we're going to read it, and we're going to talk about what all the pieces mean, and then we're going to see where I plug the numbers in. If an amount of money, P, called the principal, is deposited into an account that earns interest at a rate of R, compounded annually, then in 2 years, that investment will grow to an amount A, given by this formula. If the principal is $5,500 and it grows to $6,776.55 in 2 years, what is the interest rate? So we've got a formula here, and that's A equals P times 1 plus R squared. And A is going to be the ending amount. P is the principal or the starting amount. And R is the rate as a decimal. Okay, so what's going to go where? What is the 5,500? Is that the A or the P? Which one?
P.
P. That's your starting one. So we're going to plug in a 5,500 for the P. How much do I end with? How much money do I have at the end? That's going to be this 67.76.55, right? And what's my interest rate as a decimal? It's 6%. So 6% as a decimal then would be, it says somewhere about the 6%. Wait, doesn't. Let's make sure. That's the part we're trying to find in it, because we don't know that. Sorry about that. So we've got an ending amount, we've got a starting amount, and R is what we need to find, because we know we've got the 2 already in there. So that would give me then 67.76.55. That is going to equal 5,500 times 1 plus R, quantity squared. And I think you can finish it from there. You're going to end up using the square root property. I'll give you that hint. So square root property will be used for that. Question 12. We did one very, very similar to question 12, because that's one that has the sum of the square integers. And that would have been question 15 on page 147. So it's going to be just like question 15 on page 147. Two more to look at, or actually 3 more. We should be right on time. Now, question 13, we did one almost verbatim, like this question. And this was the sheet metal one, where I got the box over there. And so that is question number, let me find it here. That is going to be question number 27. Yep, question 27. And that's going to be on page 148. So page 148. Question number 27. Very, very similar, different numbers is all. So I don't want to set that one up because I want to leave it for you to work through, but very, very similar. Question 14. They even kind of tell you what to do. They give you this formula. Okay, so there's your initial height, this 256. Gravity's going to pull that down. You're going to drop this off the edge of a cliff. And it says, how long will it take the rock to hit the ground? So it tells you right here that the height is 0. So we want to end up with a height of 0. So on 14, all you're going to do is use h equals 0. So that is then simply going to give you 0 equals 256 minus 16t squared. And then you can solve it from here. Right? Because that's all they want you to do. Question 15. I am not going to solve it, but we're going to talk about it. Now, here's your figure. We don't have to solve this one. All we have to do is figure out what is the correct setup here. So when we look at this and we label it, what do we know? Well, we know this 3x, that's going to be your c. And that's the only part that's really important. I'll go ahead and finish it just so we know what to do here. There's not much to this one. Let's talk about the choices and see why some of these choices don't work. Why is it not A?
Because B is in front.
Right. The C has to be by itself. So this one is not going to work. So A is not going to work. What about B? Does B work? No, because they put this one in front. What about C? Does C work? Yeah, because see, it's over there by itself. And D obviously doesn't work. Why not? Because, yeah, they put the one in the wrong place. So I'll go ahead and give you that one. What should the answer for that one then be? C. And why is it going to be C? Because 3x has to be by itself squared. And so it has to be that answer C. Does that make sense on that? So that should get you started on your homework. So that's going to be your homework, is just finish up now 1.5. And I used to do the entire chapter 1 together, but it was just too much material. Because then once we get to the end of it, which would take a little bit longer, students get all confused. So that's why I broke it in half. And students just do a lot better because there's not so much material between the exams. So next week, you just look at 1.5 from your homework.